Hey, Vsauce, Michael here. This symbol, commonly called a yin-yang symbol, is a taijitsu, meaning diagram of the supreme ultimate. The principle of yin and yang, opposites existing in harmony, is associated with ancient Chinese philosophy, but the very first use of the iconography, the classic symbol, actually comes from a shield pattern used by the ancient Romans, 700 years before its first known use in China. A connection between the two has yet to be found. Regardless of who came up with it first, the symbol was a bright idea. But what's the brightest object in the entire universe? Well, apparent magnitude, commonly used when stargazing, refers to how bright an object appears to us, say when looking up from Earth. It depends on Earth-centric factors like how close the object is to our planet. Magnitudes are logarithmic and arranged like golf, where a smaller number means a greater brightness. But today, I'm looking for absolute magnitude, a measure of how bright things all over the universe, near and far, would be if we looked at them from the same distance. Absolute magnitude will guide us to the most blinding light in the universe, irrespective of it looking faint to us here on Earth just because it's far away. The difference is significant. A 100-watt light bulb placed closer than 8 centimeters, about 3 inches from your eye, will appear brighter than the sun in the sky. But that's not fair. If you could see the sun and the bulb from the same distance, the sun would be a septillion times brighter. That's bright. But the sun shines punily compared to the rest of the cosmos. If you could line the sun up with everything else out there, giving every star and cosmological phenomenon a fair chance, the sun's absolute magnitude would be 4.8. Not bad, but check out R136A1. This nuclear-fueled beast isn't the biggest star in terms of volume, but it's 256 times more massive than our sun. It's the most massive star ever found, and it's also the brightest. Remember that lower absolute magnitudes are brighter. R136A1 isn't 4.8 like our sun. It is negative 12.6, which means it is 8.7 million times brighter than our own sun. But R136A1 isn't the brightest thing out there. When a giant star dies, it explodes violently in what is known as a supernova or hypernova. As I mentioned in my video, How Hot Can It Get?, supernovas can eject terrifying flashes of radiation known as gamma ray bursts, arguably the brightest electromagnetic events in the universe. A typical gamma ray burst releases as much energy in a few seconds as our sun will release altogether in its entire 10 billion year lifetime. If WR104, a gamma-ray burst future candidate, directly struck Earth with such a beam for only 10 seconds, astronomers predict it could deplete 25% of our ozone layer and lead to mass extinction and starvation. The largest thermonuclear bomb ever detonated didn't do anything close to that, and it was exploded right here in our atmosphere. Whereas WR104 is 8,000 light years away. You can't even see it with your naked eye or a pair of binoculars. But gamma ray bursts are merely brief events lasting only a few minutes at most, sometimes just a matter of milliseconds. If you want the brightest, sustained thing, you'll paradoxically have to look at the darkest thing: black holes. To be fair, dark matter is ostensibly darker, but because dark matter has been hypothesized to not even interact with light, with electromagnetism at all, calling dark matter not bright is kind of like calling your peanut butter sandwich a not fast airplane. It's not really even the same category. Black holes, however, do interact with light, reflecting so little, well, they don't let any escape, at least not in a form resembling the way it came in. That's dark. But the intense energies created by black holes in the process of eating things like stars is anything but dark. Gas and debris from the stars they eat swirl into archipluvian cosmic gallows known as accretion disks before making their final death plunge into the black hole. In the disk, debris spins at unfathomable speeds, pulled around by a black hole billions of times more massive than our sun. Friction in the accretion disk generates heat on a level difficult to fully appreciate. Just as hot things glow, the disk does too, so brightly it has its own name, a quasar. Quasars shine thousands of times more brightly than even the brightest stars. I'm kidding. It's scarier than that. Quasars shine thousands of times more brightly than galaxies containing billions of stars. The first identified quasar, 3C273, has an absolute magnitude of negative 26.7, making it 4 trillion times brighter than our sun, about 100 times more luminous than the total amount of light produced by the entire Milky Way. If you put 3C273 33 light years away from us, it would shine as brightly as our sun, a mere 8 light minutes away. Blocking the brightness of a quasar with a coronagraph reveals that quasars exist in the centers of galaxies that are larger than them in area, but are nonetheless drowned out by their light. Such galactic centers are called active galactic nuclei, the bulk of their energy spewing forth in the form of a powerful radiation jet, the length of which puts even our solar system to shame. The visible part of the jet in this photograph, for instance, is so long it could stretch from the sun to Pluto and back 1.5 million times. Now, specifically, if a large portion of this ejected energy heads toward Earth, it's responsible for what we call a quasar. But if Earth is right in the active galactic nucleus's sights, it's got a scarier name, a blazar. And it's blazar 3C454.3 that clocked in the greatest brightness ever observed. At historically high levels of activity, it registered an absolute magnitude of negative 31.4. To put the brightness of quasars in yet another perspective, take a look at the 100,000th picture snapped by the Hubble telescope. This is a star a few hundred light years away, and this thing looks just about as bright, but it is a quasar 9 billion light years away. Why are quasars so far away? Well, a quasar is not forever. They are billions of light years away, which means the light we receive from them, the pictures we take of them, are pictures of things happening billions of years ago. They represent a phenomenon more common early in the universe's history, when monster black holes hadn't eaten all the stars around them to fuel their accretion disks, and before those holes became too fat to be active. Neil deGrasse Tyson points out that in order to remain a quasar producer, a black hole must consume about 10 stars a year. Many consume more than 1,000 stars a year, 600 Earth's worth of matter every single minute. The more stars a black hole consumes, the larger its event horizon becomes, until eventually it no longer shreds stars apart to fuel an accretion disk. Instead, it just swallows them whole in one dimmer but still terrifying gulp. Quasars are some of the most ancient things in our universe. If you could teleport instantaneously to one right now, faster than light, it would most likely no longer be burning. What we see are just their ghosts, light that left when they were active, that traveled longer than they could live. But quasars can still be born. They can even be born right here, in fact. In my video, What Will We Miss?, I pointed out that the Andromeda Galaxy is headed our way. In 3 to 5 billion years, it will collide with our own galaxy, the Milky Way, and the collision could rearrange stars near the galaxy's central black holes to be consumed, reigniting a quasar right here in our galactic backyard. Funny enough, right now, very few of us even see Andromeda, even though all you need is your unaided eye. Light from our cities drowns out the night sky like a quasar drowns out its host galaxy. Artist Thierry Cohen mocked up what big cities would look like if all their lights were off and the sky above them could be seen fully. New York, Hong Kong, Shanghai, Tokyo, Los Angeles. It's beautiful and rare. In the 1990s, during a blackout in the city of Los Angeles, a number of residents actually called the police. They were afraid of mysterious glowing clouds hovering above the city. They were seeing our galaxy for the first time in their lives. At night, artificial lights allow us to see what's around us, but we lose what's above us. The brightest places have the darkest, emptiest skies. There's yin and yang again. A Taijitu has actually been lurking in this video the entire time. The brightest things in the universe, quasars, are caused by the darkest things in the universe, black holes. The process that unshackles the most light is caused by the thing that best imprisons it. And as always, thanks for watching.